Okay, back to our show. My dog was interrupting us. So if we actually add 1 to both sides, well, we end up with a new way to look at this, which is a plus b over b relates the same way that c plus d relates to d. Right, and so there's a little bit of thinking behind this as well. We should probably kind of flesh this out. So if I look at, let's say, example, we know that 2 relates to 3 the same way that 4 relates to 6. This rule says, let's see if this is true, is 2 plus 3 over 3 the same as 4 plus 6 over 6? And in fact, we can see that, yes, in fact, 5 relates to 3 the same way that 10 relates to 6. So check. We're in good shape on that one. Part 2. We also know that if A relates to B the same way that C relates to D, this yields this product. A times D is equal to B times C. And this is just cross multiplication. Yes. And in this case, we also want to kind of draw attention to the fact that a couple of things. We say that the extremes of these two ratios, these two relationships, A and D are called the extremes, right? While B and C are called the means, which gives rise to this idea that the product of the extremes is the product, or equal to, the product of the means. It's a pretty interesting way to think about this, right? So in this case, we might think again back to 2/3 is equal to 4/6. And in fact, this is true. The extremes, in this case, being 2 and 6, so 2 times 6 does equal 3 times 4, or the extremes over here. So means and extremes. Not too bad. It brings us to another idea, which is very important coming up in triangles. And so this is number 3. And it says, if the means are the same number, then we call that number a geometric mean. Very cool. What does that mean? So again, let's think about an example. Oops. Back to here. Example. So what does this mean? 2 relates to x the same way the same number x relates to 8. And so here we have again the means, right, are the same number. When we go to the next line, we end up with this. 16 is equal to x squared. X ends up being 4. And therefore 2 relates, of course, to 4. 2 relates to 4 the same way that 4 relates to 8. But we also say that 4 is the geometric mean of 2 and 8. It's kind of cool in the sense that we also have always had this idea of the mean, right? So the mean of 2 and 8, or the arithmetic mean, is what? 2 plus 8 over 2, better known as 5, right? Because 5 is halfway between 2 and 8. But 4 is the geometric mean of 2 and 8. And that just kind of gives, for me, it ends up feeling like a kind of a weighted mean. Oops, let me see if I can get this next page over. There we go. All right, so a weighted mean. So if you think about a number line, let's see, 2, 2, 3, 4, 5, 6, 7, and 8, right? Now 5 is exactly in the middle, and 4 is a little bit closer to 2. And so I always feel a little bit like a geometric mean gives this sense of weighted, right, that we're weighting the geometric mean a tiny bit closer to the smaller number, where 5 falls exactly in the middle, right? These two things are exactly the same. This number is going to be pretty important to us kind of going forward. And so to recap, the geometric mean mean of A and B can be found by setting this up. A relates to X the same way that X relates to B. I've also had students kind of get used to that and saying that X squared equals A times B, or X is the square root of A times B, right? And so that ends up being the geometric mean. I want to go back a tiny bit and see if I can put some other form in here. And that is, we have a couple of other rules that we should probably cover. So let's go back and call this 2A. This one is not as intuitive. And that is that if A relates to B the same way that C relates to D, right? It turns out that we can also have this same ratio. A will relate to C, or the numerators relate the same way that the denominators relate. Algebraically, not hard to see this one, right? We end up with, let's see, AD relates to CB, right? And then if we divide both sides by C and then divide both sides by D, we end up with A over C relating to B over D. And again, always good to have an example. 2 relates to 3, same that 4 relates to 6. Also allows you to kind of look at the fact that 2 relates to 4 the same way that, right? So the numerators relate in the same way that the denominators relate. Great. And last idea, which we'll give to B, and that's 2B. This is very intuitive. If A relates to B the same way that C relates to D, then we can switch. Then B over A relates to D over C. relates to 4/6 gives rise to 3/2 is the same thing as 6/4. Right? And this one, right? End of 5.1 video. Okay.